Hello, this is Dr. Yamada. In this video, I'm going to talk about the concept of a paired sample t-test. Before I begin, I wanted to let you know that I'm going to talk about this video based on the premise that you have already watched the level 1, the concept of an independent t-test. So it's a continuation from the previous video. So, what is a pair sample t-test? A pair sample t-test is inferential statistics that evaluate a statistical significance between two dependent groups. When we talked about the independent t-test, data must be independent. In this case, for paired sample t-test, the data must be dependent, which we will talk about it later. So when can you use it? The research questions that you can use for a pair sample t-test are almost identical to an independent t-test. Like, is there any difference between two different groups or two different interventions, two different protocols? Or is one better than the other? So those are the questions. You can also ask an additional question using a pair sample t-test. That's when your research question is whether participants will improve after the treatment compared to the before the treatment. So also the conditions when you can use a pair sample t-test are very similar to an independent t-test, except for a few differences. Situation is you don't know the population mean and standard deviation, and you want to compare two dependent data, and also the independent variable must be categorical, the dependent variable must be continuous, and normality assumptions must be met. However, the two differences from the independent t-test situation is the data must be dependent and you do not have the homogeneity of variance assumptions. What does it mean by two data are dependent? Data are called dependent when two data are correlated or related with each other. So, for example, the situation where you use a paired sample t-test is all participants you recruited will experience both interventions. So when we discussed an independent t-test case, you recruited participants and you have to split the participants into half, right? However, in a pair sample t-test situation, all participants you recruited will go through both interventions. Because of the difference, we often call conditions instead of groups because they are not two separate groups. Rather, there are two different conditions where all participants experience both. Another example where a pair sample t-test is appropriate and when the data are dependent is all recruited participants experience only one intervention or treatment. However, the dependent variable are collected two time points. In these two scenarios, this type of study design is called within subject design or repeated measure design. Okay, so why data are dependent? Because when all participants experience both conditions, you will have two data or a pair of data sets for each participant, right? So this data point and this data point, it doesn't matter if it's before or after or condition 1 and condition 2, those data are collected from the same individual. Therefore, these two data points must be correlated or related with each other because it's coming from the same individual. When in the case of independent data, this data point and this data point come from two different individuals. Each participant is measured only once. Therefore, the study design is a between subject design. So, the strength of this within subject design is because you have two observations for each participant, you can measure the change within each individual. So, it allows you to observe individual difference. If you know the individual differences, then you can remove that. And this individual differences is one of the largest factors affecting the variability of the data. So if you can remove that, you can get a better statistical results. Therefore, within subject design is typically the weakness of a within subject design is the order effect, because the second time measurement is always influenced by the first time measurement. For example, let's say condition 1 and condition 2. You can you could potentially conclude that condition 2 is better than condition 1, but bec- it could be just because this data was measured the second time, and so the participants may get just better. But in fact, there is no actual effect of the interventions. This is the biggest weakness of this study design. So, one method to remove this order effect or reduce this order effect is a counterbalancing the order across participants. Meaning, if you recruit 20 participants, 10 participants will experience condition 1 first and then condition 2, and the other 10 participants experience condition 2 first and then condition 1. So, theoretically speaking, the effect of the order be the washed out. So, for the statistical procedure, the mathematical there are mathematical differences between a pair sample t-test and the independent t-test. However, they're conceptually the same. So you first need to set up the null hypothesis and alternative hypothesis, which is your research hypothesis. And you can create a two-tailed hypothesis or one-tailed hypothesis. And after you set up the hypothesis, you determine an alpha level, which is usually zero point 0.05 or zero point 0.01, and then the degrees of freedom of a pair sample t-test is n minus 1. Remember, the degrees of freedom for an independent t-test is capital N. So the N is not the capital letter, but indicates the number of pairs. Skipping the mathematical part, after you run a pair sample t-test, what you will obtain are a t-score and a p-value. And if the p-value is less than the alpha level you set, it means statistically significant. Therefore, you reject the null hypothesis and you support your research hypothesis. And descriptively speaking, you will mention that there was a statistical difference between the two interventions. And how to write the results are also very similar to the independent t-test case, where you put the t and within the parentheses you insert the degrees of freedom, t-score, separate by a comma, and the p-value. And make sure you also include the descriptive statistics. Traditionally, we don't report the critical value. Okay, in another scenario where you obtain the p-value that's higher than the alpha you set, that means you fail to reject the null hypothesis. Therefore, it indicates there is no statistical significance, and therefore, you're not supporting your research hypothesis. Lastly, additional information. The p-value doesn't tell you anything about how different the two interventions were. Therefore, you need to report the effect size, which is the quantification of the magnitude of the difference between conditions. So it's important to note that the mathematical calculation of the effect size is different from the between subject design. So you need to use a different formula.